So our first show me video for you to take notes on is over functional relationships. Our focus thought is, what is a functional relationship? And how can I tell whether a relation is a function? So a couple important definitions are going to be right here. Okay, so everything that's on here you need to write exactly like you see it. This is how I'm going to have it in my notebook, and this is how you need to set it up in your notebook. So that left column is important definitions. Okay, so the first one is a function. We have a couple different bullet points with information. The first bullet point is a relation, which is just a set of numbers, okay, a bunch of numbers, in which each x is paired with exactly one y value. Okay, so in order for a relation to be a function, each x is paired with exactly one y value. The next bullet point is a relationship between two quantities in which one quantity depends on the other. And we've talked about independent and dependent quantities. The next definition is a relation, which is just a set of ordered pairs, okay, a set of numbers. The next one is a mapping, the pairing of each x value with the y value in a specific fashion. And I'll show you in just a second what I mean by that. The last definition is the vertical line test, which we're going to use. It's a test to determine if a relation is a function or not on a graph. Okay? The vertical line that we draw cannot intersect our graph more than once. If it does hit more than once, then it's not a function. So on the other side is important information or steps. Okay? All functions are relations, but not all relations are functions. That might be a little confusing right now, but as I show you examples in a second, that'll become more clear. Some of the ways that we're going to look at today are here. We can look at ordered pairs, mappings, graphs, tables, equations, and verbal statements. We may not look at all of them, but this is just, all the ways that we can represent information. Remember, an ordered pair has to look like x comma y. Just think alphabetical order. I have a little asterisk here. Okay, tables and ordered pairs are very similar. We're just looking at them either horizontally or vertically. Okay, so just keep that in mind. A couple important things that I wanted to put in here that I wanted you to write are down here. Just a couple tips. When identifying a functional relationship, you always have to remember to look at the x values. The x values cannot repeat, but the y values can. For example, two people can have the same height, but the same person cannot have two heights. Okay, so just keep that in mind. Just think of something funny, like, oh, I can't go back to my ex, right? She's crazy. I can't repeat that time in my life, right? My ex is crazy. So just think about little quirky ways to remember this stuff. So this is how I want you to set it up on the next page, or however your notebook looks like. I want you to make 3 different columns. The first one can be kind of smaller. It's just going to be type. So our first type is going to be ordered pairs. Okay, and then I'm going to show you an example of a function and a non-function. Okay, so when I say function, that means the x's don't repeat, right? And then relation, they may repeat. Okay, well, they're probably going to if I put an example like that. Okay, so my first example of a function, I'm going to put some squiggly brackets to show that this is a set of numbers, and I'm just going to write some ordered pairs. Okay. So notice, remember, it's always x comma y. The x's 7, -9, -7, and 2. The x's don't repeat. Even though the y's do, I don't really care. All I care about is the x's. Okay? A non-example is -6, 15, 8, 13. So good or it's good so far, right? Negative 6 and 8 are different, obviously. Okay, but then this last one kind of ruins it. Negative 6 and negative 6 are both the same x value. So that is a relation. It's not a function. One special case that I want to mention. So write this also. If I have 2 comma negative 3, some more ordered pairs, okay, so let's say I go through and I look and say, okay, 2, 7, negative 9, negative 7, 2. Uh-oh, it repeats, but this isn't a different y value here, right? This is 2, negative 3, 2, negative 3. This is the same ordered pair. So in this case, it would still be a function because those are the same, okay? So if you see that it's the same exact ordered pair, it's fine, okay? But if it's a x value with a different y value, that's when it's a problem, okay? So the next kind we're going to look at, next type of relationship is a table. So just draw yourself a little t-chart, x comma y, x comma y, okay? So let's say on the first one we have negative 4, comma negative 16, negative 2, negative 8, 6, 24, and then 10, 40. Okay, obviously none of them repeat, right? These are all different, so it's a function. On the relation side, if I put, say, negative 7, 19, negative 2, 12, negative 2, 10, and then 5, 2. Repeating x values, different y values. So this would definitely be a relation and not a function. Same rule applies as the ordered pairs. If this was negative 2, 12, negative 2, 12, it would be fine. It would be a function. But because the y's are different on these x's, that's our clue. Our next type of relationship is a mapping. Okay, you should have seen these when we did ways to represent numbers in multiple ways. Okay, so I'm just going to draw 2 big circles on each. Let's say we have negative 1, 0, 1, 2, and then 0, 1, 2, 3. Negative 1 goes to 0, 0 to 1, 1 to 2, and 2 to 3. Okay, each x value goes to one specific y value. On this other side, a non-example, let's say we have 1, 4, and 2, and then 2, 5, negative 5, 0. 1 goes to 2. Oops, sorry, my lines are kind of crookedy. 4 would go to 5, and then 4 also goes to negative 5, and then 2 to 0. So my x value, because it's always x and then y, x on the left, y on the right. My x, 4, is repeating. It would be 4 comma 5, and then 4 comma negative 5. So this is what a relation or not a function would look like on a mapping. Our last type of representation that we're going to look at is a graph. Okay, so just sketch out the graphs just like I'm about to do, okay? So for some examples, again, this is the vertical line test. Can y'all see that? Whoops, sorry. So the vertical line test is what we're using right now. I'm just going to draw an x and y coordinate plane. I'm not going to make sure it's all pretty. I don't care that much, okay? So let's say I have some squiggly line like that. I want to draw a single vertical line. I should be able to put that vertical line anywhere on my graph. So let's say I put it here. How many times does that vertical line hit my graph? 1 time. Okay? And if I moved it anywhere, it would still only hit it 1 time. Okay? So another example of a function, whoopsie, would be our absolute function. You'll see that in Algebra 2 and be more familiar with it. So if I draw a vertical line anywhere, it should only hit it once. So if I moved this vertical line, it would only hit it one time everywhere I moved it. So these are both functions. A non-example would be like a circle. A circle, if I drew a vertical line, would hit it here and here. Okay, so it hits it twice. Therefore, those x's would be repeating. Let's say this was 2, comma, -1. This would be 2, comma, 1, 2, maybe 3 or 4. So same x values repeating, different y values. No, no, no. So that would just be a relation. Last non-example, if we had this little guy, something like this but turned sideways, right? Kind of opens to the side. Looking at this, I can draw a vertical line, hits it twice. Okay, so that would definitely be a relation and not a function. So this is just a little bit about functional relationships. Please have these notes ready to go for Miss Tucker when you get back to class on Monday.